Good morning. Myself, KV Muralidhar Sharma, a research scholar in ET, Educational Technology. I'm working on developing an engineering thermodynamic learning system at VTU, Karnataka. Of course, the domain on which I am deliberating is on basic thermodynamics. The concepts being the thermodynamic systems and boundaries, and the dynamics of the systems and boundaries. To be precise, what we are expected to learn after going through this video: two things. One is to define the thermodynamic system and its ancillaries, namely boundary and surroundings. To define a thermodynamic system, boundary and surrounding. And number two, define different types of systems and different types of boundaries. Let's quickly get into the first object. What is a system? Academic definition academic definition of a system is something or some portion of the universe that we wish to study. To make it more thermodynamically specific, a thermodynamic system can be defined as a quantity of matter, or simply a matter or a region that we choose to study. A quantity of matter or region in the space that we choose to study. So this does not really serve our purpose, because more than defining, we are probably confused it a bit by introducing so many abstract terminologies like some portion, a quantity of matter, a region in space, a quantity of matter, we wish to study, universe. These are the terminologies. Looks like we are studying something about philosophy, but it's not the case. The reason why it looks a bit absurd is the unfamiliarity of these type of terminologies. Unlike in other subjects like mechanics, in either in mechanics or design, we use terminologies, known terminologies like rigid body or kinematics, a machine which we can see, a rigid body we can see, a link we can see, whereas we can't see space, we can't see the matter, we can't see the region. So these abstract terminologies is what makes this bit typical compared to the specific terminologies that of the other, unlike the other branches. That is why the definition looks bit uh, different. Anyhow, that is exactly the advantages. That's exactly the typicality of the thermodynamics. Let us try to see what are the things we study in thermodynamics. In thermodynamics, to be specific, to make it more general, we can study everything and anything and everything. It can be an aeroplane, it can be a power plant, it can be an air conditioning system, it can be a refrigerator system, or it can be a human being for that matter, or a tree. So what is the meaning of this? What we study, that becomes a system. If we are studying air conditioning, that becomes a system. If we are studying a power plant, that becomes a system. So when we study anything and everything, in so we are studying anything and everything in the universe, we will be studying either a quantity of matter or a region in the space. A region in the space refers to a volume, or a quantity of matter refers to mass. We study either a fixed mass or a fixed quantity, fixed quantity of matter or fixed region in the space, a volume or the mass, the two variables that we are studying. The concept of what we study, or the concept of system, is incomplete without referring to what is called as boundary and surrounding. If I say I'm studying an air conditioning system, the question comes, what part of the air conditioning system I'm studying? Is it the entire air conditioning system? Is the air conditioning system along with the room? So many questions. So we need to put some confinements, we want to put some limitations, we need to put, that means, some boundaries. That is where the concept of boundary comes. Again, when it comes to the question of power plant, a question comes: what is that we are studying in the power plant? Is it that the cooling tower we are studying, or the entire power plant, right from the entry of the coal until the uh, exhaust, or only the exhaust that we are studying? Depending upon the requirement and depending upon the problem definition, we may need to study different things. Suppose if we are studying only the exhaust, what is the quality of the exhaust and what are the ill effects of the exhaust on the environment, probably a cooling tower and other part may not constitute the system. So the question we are trying to address here is, what we study is our choice, is the choice of an engineer, what we need to study depending upon what is that we want to achieve. So accordingly, a definition of the system also differs. But irrespective of all these things, a system cannot be defined without the boundary. If we simply say we are studying the power plant, it does not make sense, unless otherwise we bound ourselves with what we are studying. let's see the same let's see some examples along with the boundaries. So here the red dotted line gives the boundary. We are studying some reaction within these vessels, with some mass interactions, with some energy interactions. So here, example A, we are studying a flow, the flow characteristics, the effect of different parameters on this energy and the energy transaction. So the question comes, where is my system, where is my system, where from it starts and where from it ends? We need to put certain boundaries. You can see we need to put certain boundaries. Without the boundary concept, the concept of system is incomplete, and it cannot be understood. Again, you can see a boundary, in studying an IC engine, a piston and cylinder arrangement, the energy transaction and the mass transactions. If we are studying this, the concept of boundary becomes very essential. And to put it other way, without the concept of boundary, system is incomplete. A system and boundary are inseparable. Having understood what is a thermodynamic system, understanding thermodynamic system as a region or a matter, a volume or the mass that we focus to study in the universe, anything other than a system becomes the surrounding. Anything outside the boundary of the system becomes surroundings. And obviously, what differentiates between a system and the surrounding is the boundary. Boundary is the surface that separates the system and the surrounding. What distinguishes what is not in the system and what is not outside the system is the boundary. In the next video, let us study about the last and the second objective, about different types of boundaries. To quickly recapitulate, we have focused on the first part of the learning objective. We have defined a thermodynamic system as something, matter or region, that we are focusing to study. And these terminologies, which are not specific and which are more abstract, is what makes us looks like, system as more a bit difficult or a bit different, whereas this is exactly this abstractness which gives us the freedom of uh, defining the system and defining, and I mean, this is what this is what makes the subject more universal. We can study and anything and everything, but when we say anything and everything, based on the requirement, we need to fix the boundary, and that is what defines the system. A boundary is what differentiates between system and surrounding. Anything outside is a system, anything outside the system is a surrounding, and inside within the boundary is a system. Thank you.